Hi, welcome to Math Minute. My name is Adam, and today we're going to be talking about systems of linear equations. So what a system of a linear equation is when we have two equations and two variables. There's a connection between that. In order to find each of the variables, we need two equations to find all the information we need. So we have two methods, and I'm going to start off with substitution, and here's an example of a system. The very first step, and I'm going to give you a list of steps, and what I recommend is that you write these steps down. They're great steps, but I've always found that it helps to rewrite these in your own words. By all means, if these are the correct words that you feel that really help you, just use them. But if you want to rewrite this a little bit, that's great too. So the very first step is solve for one variable. So this, as you see, y is already by itself almost. It doesn't have a constant in front of it. So what we're going to do is we're going to solve for y. We're going to choose either equation, so let's choose this one. So all we have to do is subtract 3x from each side. So y equals 14 minus 3x. So now what we need to do is take this and substitute it into there. That's step 2. We're using both of the equations. We need to use the opposite equation that we just solved for. So now we're going to say that 2x plus y, but we just found that y equals 14 minus 3x. So let's put that in its place. 14 minus 3x equals 11. Now we have an equation just in terms of x, and we can solve that easy. We can find out that x actually equals 3. So we have half of it done. Half the battle's gone. What we need to do now, the final step, is find the other value, and that in this case is y. We can't just give x as an answer. We still don't know what y is. So we can plug this x equals 3 into either of these equations, or even easier than that, we can plug it right back into here because we're trying to find y. So we know that y equals 14 minus 3 times x, which x equals 3, as we just found. And this says that y equals 5. So our solution is x equals 3, y equals 5. And to check that, we can plug these two values into both of these and see if it's correct. 3 times 3, which is x, plus 5, which is y, equals 14. 2 times 3 plus 5 equals 11. This one checks out. That's good. Now the second example is elimination. And this is when substitution doesn't exactly work, or it's really difficult to make it work. As you see, each variable has a coefficient with it. So it's a little bit more difficult than it was over here where we could solve for y easily. So what we're going to do is we're going to stack the equations. That's step 1. So let's put 4x minus 2y equals 10 on top of 2x plus 7y equals negative 3. Now we're going to treat this like grade school addition. We're going to add it together in a row. So what we need to do though is this is where the elimination idea comes in. We want to eliminate a variable somehow. If you notice, if we were to multiply everything on this bottom equation by negative 2, this would become negative 4x, which when adding these together would eliminate the x variable. We could also do this with y, but that gets kind of confusing, so let's choose what's easy. So let's multiply this whole thing by negative 2. Okay? Now what we'll have is 4x minus 2y equals 10, exactly what we had before, and then negative 2 minus 2x, so we have minus 4x minus 14y equals positive 6. Now when we add these two together, we have 0, 4x minus 16y equals 16. So we just multiplied by a constant and eliminated the variable. So now we just have y, and we can solve for y, saying y equals negative 1. Once again, we have y, but we need x. So we can take this, plug this into either of the equations, just like we did for substitution. So let's just say 2x plus 7 times y, which we now know is negative 1, equals negative 3. And if we solve this, just like we did before, we can find that x equals 2. So we have our solution. X equals 2, y equals negative 1. Okay? Now, we can do the same idea to check. Plug x in here, which is 2, and also plug y in here, which is negative 1. 2 times 2 plus 7 times negative 1, negative 3. 4 times 2 minus 2 times negative 1 is 10. So we've checked. They're both good. It's a good solution. So just like we did here, we went through the steps that we were given, plugged it back in, checked our answer. We have a different set of steps for elimination when the problems get a little more fuzzy, and then solve for and check again. So my recommendation is that you go through these steps, do a couple problems, and maybe make up your own steps, reword them. And that will help you understand, have a better understanding, a deeper understanding of what to do and how to solve these steps. So hopefully this helped you solve some systems of linear equations, and we'll see you next time.